Welcome back friends, my name is Satyajeet Sahu and we are in our Hpcl, Bhel and TSPSC series. So sorry for minor delay in the broadcasting, okay. So we are live from BYJU'S studio and today we are going to see hydrology and irrigation. Yes, hydrology and irrigation is an important topic for your Hpcl examination or Bhel examination or any PSU examination. Yes, so let us see the most probable question which they can ask from these two subjects. Okay, so welcome Sarfaraz, Vipul, Rasmita, Survi, Aftab, Afreed, Naman, Ans, Nikki, Anu, Akans, Ankit, Vivek, Jays, Naivedya, Diya and Juhi. So welcome all the participants and warm welcome to all the people who are seeing this lecture recorded. Okay, so let us start this series. Before that, some announcement. So we have Formula 1 series going on where we are discussing all the important formulas. So please do visit the channel and see the videos. Yes, and then I'm happy to announce that we are having All India series, test series for GATE and ESE. So interested students can register for this by downloading the BYJU'S Exam Prep app and they can explore and see that which test series they want to take. Yes. So let us start with the series and let us start the questions. Okay. Welcome Punmathi. Okay. So answer this question. The area under a hydrograph represents what? Come on, answer the question. The area under hydrograph represents what? So the comments are here. So I am seeing the comments. So please answer in the comment section the answer to this question. Yes, very good. It represents what? It represents the intensity versus, first of all, what it represents. If we are plotting, it represents what? Intensity, the rainfall intensity, yes, versus the time. Yes, the rainfall intensity versus the time, right? So if we take the area, yes, see they're not asking the plot. If we take the area, yes, if we take the area, what we will get? We'll get the total rainfall. Yes, we'll get what? We get the total rainfall, right? Because you see intensity will be in what? Centimeter per hour, right? And time will be in hour. So if you multiply, what you will get? You will get centimeter. That is what? The total rainfall. So area is what? Total rainfall. So if they ask you what is the plot is between intensity and time, or we can say duration. But if they ask you what the area represents, it represents what? The total rainfall or total precipitation. So A is the right answer. Next question. Okay. So we have a numerical. Okay. So we have a numerical. Okay. So I will solve this numerical for you. You see, the class A pan is given, right? What we do in this, we try to find out the evaporation, right? You see, the evaporation measured was 5 mm per day and the pan coefficient is 0.7. So what is the actual evaporation? What is the actual evaporation? The actual evaporation will be the pan coefficient into 5, right? So this will be equal to 3.5 mm per day, right? Now this is what? This I can say sort of depth. If I want to find out the volume of water which got evaporated, how to find out? The volume will be equal to this depth into area, right? This depth into area, right? Now what they're asking the volume of water evaporated in a month of 30 days. So volume in 30 days will be how much? This you will get in what? This is mm per day. So this will get in per day. If you want in 30 days, what you will do? You will multiply 30. Yes, rest you have to take care of the units. So Afrid has answered B. So take care of the units and give me the answer. You have to take care of the units. The final answer is in meter cube. So give me the answer to this. You see, this kind of questions you can easily solve by just seeing the units, right? Because they're asking you volume. So volume is what? Meter cube, right? So tell me what is the volume evaporated? What is the volume evaporated? See, they will ask you numericals also like this. You have to be ready. See, depth is 3.5 mm. So 10 to the power minus 3 meter. Area will be what? You see, the length is given and the width is given. So 80 kilometer is 80 10 to the power 3 meter and then 50. This I will get for per day. So I'll multiply what? 30. So as many students are telling, we are getting how much? 126000. Okay, so this is the standard question which they can ask in the examination. So we are solving the most probable questions for hydrology and irrigation. Next question, which of the following is a non-recording rain gauge? Please answer in the comment section. Which of the following is a non-recording rain gauge? Non-recording. Non-recording means I can say it's not automated. Which of the following is a non-recording? Yes? Yes, okay. The answer is Simon's rain gauge. Yes. So we have two types. Yes, recording and non-recording, right? So the Simon's rain gauge belong to non-recording all the three types. Tipping bucket, okay, weighing and floating type. Another one is your siphon rain gauge. All those belong to what? Recording type. The next question. For a large catchment, contours joining points of equal rainfall, okay, contours joining points of equal rainfall were plotted. The plot is known as what? Points of equal rainfall. What we call that? Points of equal rainfall. What we call that? It is isohydral. It is what? It is isohydral map. So isoheight is what? I can say isoheight is map. So I can say isoheight is what? Line joining points of equal rainfall. Equal rainfall. Okay. Okay. Next question. Okay, answer this. Answer this question. Read the statements. Two statements are there. H1 statement is there and H2 statement is there. Which statement is true? Which statement is false? Please mention in the comment section. I am seeing your comments this side. Please mention. Please read the question and answer this. We know that in a hydrograph we have two limbs, right? Hydrograph is a plot between what? The discharge and time. Yes. So first we will get a rising limb and then we will get a falling limb, right? Or I can say recession limb. This is the falling or recession limb. Yes. So what is the right answer? Yes. The right answer is both statements are wrong because the rising limb, okay, it depends on what? Both catchment. It depends on both catchment or I can say basin characteristics. Yes. And the storm characteristics. Storm means what? The rainfall. And also it will depend on the area on which the rainfall is occurring, right? Basin or catchment means what? Where the rainfall is occurring. Whereas the recession limb only depends on what? The catchment. Yes, it only depends on the catchment. Because the recession limb start when the rainfall has stopped actually. Yes, so I can say this is the right answer. So here the just reverse is given, right? So both are wrong. Next question, what is the right answer to this? The intensity of irrigation means what? What is the intensity of irrigation? What is the meaning of this? 4 definitions are given. Please mention the right definition. I am seeing comments. Today we'll make it a little fast. The intensity of irrigation, what is the meaning of that? What is the intensity of irrigation? What is the intensity of irrigation? No answer? Don't know? Okay, our comments are not coming. D. Intensity of irrigation is the percentage of cultivable commanded area. Yes, it is the percentage of cultivable commanded area to be irrigated annually. See, suppose we have area. An area is there. This is known as what? The gross area. This is what? The gross commanded area, or I can say GCA. This is what? Gross commanded area. Now, the whole area will not be cultivable, right? You cannot do cultivation in the whole area. So I can say suppose a certain area is what? Cultivable. So this is what? The cultivable commanded area. Now, in a particular year, you will not use the total cultivable area for irrigation, right? Yes, you will not use the whole area. You might be using this much area. Yes, yes. So this intensity will give me what? The area irrigated, right, the area irrigated by what? The culturable commanded area. Yes, or I can find out, see, if I know the intensity, I can find out the area to be irrigated, right? I can say that the area to be irrigated will be what? Will be equal to the intensity into cultivable commanded area. If they ask a question, which one is more, GCA or CCA? So obviously the answer is what? Your GCA is more. Yes, GCA is more. So next question, seventh question, answer this basic definitions. The ratio of quantity of water stored in the root zone of the crops to the quantity of water actually delivered in the field. Yes. See, when we are delivering to a particular field, okay, water, yes, suppose you are delivering Q1 water, okay, all the water will not be stored in the root zone, right? There will be some losses. And suppose the stored one is Q2. So Q2 by Q1 is known as what? What is answering? The answer is water application efficiency. The answer is what? Water. Many people answering. Very good, very good. Answer is C. Water application efficiency. Next question. Okay, so we have this delta duty question coming, right? So in irrigation and hydrology, always they ask a question from delta and duty. So please solve this question, answer me. Just be little careful of the units. So answer me this question, question number 8. I will just tell you, be little careful about the units and answer this question. So we are solving questions from hydrology and irrigation for upcoming examinations. Okay, you see, I told you have to be little careful of the units. Little careful of the units. The formula is, duty is equal to 8.64 B by delta, right? But here you have to understand this D is in what? It is in hectare per cubic or cubic meter per second, right? And then this B is in what? This is the base period in days, and this delta is in meter. You have to understand this thing, yes? So it will be 8.64, base period is given 100 days, and then the depth of irrigation is 100 centimeter, that is what? 1 meter. So it will be how much? 864, as many have answered. Very good. Next question, ninth question. Okay, the storage capacity of soil is asked. Field capacity is given, permanent wilting point is given, specific dry unit weight is given, the depth of root zone is given. They're asking you what? To find out the storage capacity of soil, means how much moisture or water it can store. It can be also called as what? I can say maximum available moisture. Maximum available moisture, right? Maximum available moisture. So what's the answer? Many people answering C. Let us see it is C or not. What's the formula? It is gamma D by gamma W, right? Then the depth of root zone into the field capacity minus the permanent wilting point. Now you see, we have to find out the available moisture or storage capacity in centimeter. So we'll put the D in centimeter. So this is gamma D is 1.5, gamma W will be 1 if we are taking gram per cc. D is what? 80 centimeters. So we'll put that. These capacities we should put in decimal. So 0.25 minus 0.15. Don't put in that value, otherwise you will get wrong answer. So it is, I can say 0.1. So 8 into 1.5 is how much? Your 12 centimeter. Very good solving. Which one is the best method for reclamation of alkaline soil? Please answer this question. What is the best method for reclamation of alkaline soil? If we have alkalis in soil, okay, alkalis means what? I can say sodium carbonate, salts of your sodium and potassium. Okay, so what is the answer to this? Tell me. What's the answer? Vivek is writing C. Okay, when you are writing C, the answer is actually B. See, leaching is there. Yes, what is leaching? We flood we flood the field. So what will happen? When we flood the field, then what will happen? The salts or the alkalis will get mixed with the water and they will get drained out, okay, in the subsurface flow or surface flow, right? Then if you add gypsum, what is gypsum? Gypsum is CaSO4, right? So when you add gypsum to this, yes, then what will happen? These get converted to what? Na2SO4, and this can be easily leached out. Leached out means what? It can be carried by the water. Yes, and therefore I can say both addition of gypsum and leaching, both are good. Next, 11th question. Watering done prior to sowing of your crops is known as what? Very simple question, very simple theoretical question. You see, they can ask you numerical also, they can ask you theory questions also. You have to be mixed, you have to prepare both. So answer me this question. Watering done prior to the sowing of the crops is called what? D, yes, it's known as paleo irrigation. Direct question. Next question, okay, what is this? Something is written, some definition is written, yes? Some definition is written and they're asking you what is this thing called. So please read the definition and answer that what is they are referring to. What is this 12th question's answer? Some definition is given, they're asking you what is the definition exactly. Yes, others, what happened? C, duty, delta, A, many answers. The answer is duty. You see, we have three terms, right? Base period is what? Base period is the period of irrigation, yes? And it will be in days, okay? Now, what is your delta? Delta is the depth of irrigation, right? Delta is the depth of irrigation. Yes, it's a depth of irrigation. And it will be in meter, right? Now, what is duty? Actually, duty is what? It is the area irrigated when a discharge of 1 meter cube per second is provided to the field. Yes, for how much time? For base period time. Okay, for base period time, if you provide 1 meter cube per second, then what is the area irrigated? The area irrigated will be what? The duty. And therefore from this actually we get that formula. We'll derive that formula in short. You see what I am telling? Discharge is 1 meter cube per second and the time is B days. So what is the volume? What is the volume? Tell me. The volume generated will be how much? 1 meter cube per second into B days. So B days means what? 1 day is 24 hours, 60 minutes and 60 seconds, right? So I'll get what? This much meter cube of water is provided to the field. Now, how much area will be irrigated? That will depend upon the depth of irrigation because this volume will go to the field and this will become what? The area of irrigation into depth of irrigation, right? And I am telling that this area is what? Duty. This area is known as what? Duty. So duty in hectare. Duty in hectare. So this will be what? 10 to the power 4. Yes, hectare into meter square is what? 10 to the power 4. And depth I am mentioning in what? Delta, that is meter. So when you equate these two, what will happen? Then you are getting that equation what? That your duty is equal to 8.64 base period by delta. Yes or no? This 10 to the power 4 is there. You see this will get cancelled. Then this will become what? 864 then divided by 10 to the power 2. That is what? 8.64. Yeah. It's beneficial for every exam. See, try to understand one thing. Many students don't understand this. The prelims of ESE and any other exam, most of the questions are same only. Yes, we can say that 60% questions are same only. Yes, so it helps. Okay, Santu, that question was for me actually. So let me answer. I am the teacher, right? Yes. Okay. 13th question. Calculate the water distribution efficiency if the depths of penetration along the length of a border strip at an interval of 20 meter are 1.5, 1.8 and 2.1. So this is what water distribution efficiency. How to answer this? I will just tell you the formula and we'll discuss this. You see, suppose this is the ground level. Yes. So we have, you can see that the depth of penetration are Y1. This is suppose Y1. Yes. This is suppose Y2 and this is suppose Y3. Yes. So Y1, Y2 and Y3. See, Negi, just by spamming just by writing random answers, if you are thinking that you are getting benefited, actually you are wasting your time. So please don't waste your time and don't waste my time. And if you think that I am going to entertain you, if you think that I will feel, oh wow, you are doing some great job, or I will feel that, okay, I will also, encourage you, so I'll discourage you. I will tell that what you are doing is time waste. So please don't, comment randomly if you don't know the answer. Okay, please don't do that. Okay. Now Y3. Okay, these are the depth of irrigations. Okay, you can say depth of penetration of water. Now Y will be what? I will get a term D, sorry. This will be what? This will be the average penetration. We can find out the average penetration, right, easily. Yes. And then we will define a term Y. What is the Y? It will be the mean deviation. It will be what? Mean deviation. And when you calculate the mean deviation, it has to be what? It has to be your absolute deviation. Means what? You see, the average penetration will be how much? It will be 1.5 plus 1.8. Do I have another slide? No, I don't have slide. So 1.8 and then 2.1 divided by 3. So I can say the average penetration is coming how much? It is coming 1.8 meter, right? It is coming 1.8 meter. Now if I see the deviations, you see from this the deviation is how much? 1.8. So deviation is how much from the mean? It is 0.3, but I will take what? Your absolute value. So deviation is 1.5 minus 1.8. I will take the absolute value, right? Then the next is what? 1.8 minus 1.8. And the last one is what? 2.1 minus 1.8 and then what? Divided by 3. So how much are getting this? We are getting this as 0.2, na? We are getting this as 0.2. So very easy. Now this water distribution efficiency will be how much? Straightforward formula, 1 minus Y by D into 100. Very straightforward formula. Very good, Santu. Very good, Santu. Santu is revising. Santu is revising and coming to class. Other students, please revise and come to class like Santu. Okay, it will be beneficial. So next is what? 0.2 by D is how much? Your D is 1.8. Yes. So tell me the answer now. How much you are getting this? First, sir, आज first time आया हूँ. So please just sit silently and listen what is going on. So if you don't know the answer, don't randomly comment. If you don't know the answer, sit and then try to understand what is going on in the class, right? Yes. Okay, so what's the answer now? Everyone is getting this answer? Yeah, we're getting 88.88 and it is expressed in decimal here, so write down what? 0.8889. Understood this question? Try to understand. They can ask you numericals and these are short numericals. If you have practiced this, Santu found out within 1 minute also. So if you have practiced it, you can easily solve. 14th question, okay. What is the variation in duty of water from the head of the main canal to that of field? Here I will give you one small line, you can answer this, okay? Answer this question, 14th question. So we are comparing the duty at the main canal and then in the field. See, main canal will be here, then the water will be provided to the field, right? So if your duty is here D1, here duty is D2, so duty will increase or decrease or what? Okay, if you don't know, I am telling you. Remember this, duty always increases as we move from your main canal to field. Why so? Because you see the losses will increase, right? When you're going from the main canal, at the main canal, what will happen? The losses will be less. Now, when the water is reaching the field, there will be losses. So, duty has to increase, right? So, what is the answer? The duty of M at M will be less than that of F. Because as you move from the main canal to the field, yes, what will happen? The duty will increase. Understood this thing? Yes? Okay. Next, okay, 15th question. So this is an irrigation question. Sorry, the amount of discharge question. So I will explain to you this question. Okay. Now, whenever you want to find out the discharge to be provided for irrigation, they ask you a question, discharge to be provided. The discharge to be provided will be the area to be irrigated by what? The duty. Yes. So the area to be irrigated by duty. Now, if you are irrigating two crops, okay? If you are irrigating two crops means what? Crop 1 and crop 2. Yes. And suppose both of them belong to the same season. We have Rabi season, we have Kharif. Yes. So if both the two crops, yes, they belong to same season, then what I will do? I will find out Q1 discharge for the crop 1, then find out discharge for the crop 2, and then what I will do? I will take this as the design discharge. I will take this as what? Design discharge, right? But if I am irrigating for crops in two different seasons, okay? They belong to different seasons. They belong to different seasons. So what you have to do? You have to find Q1 and Q2. Now different seasons means both irrigation will not occur at the same time, right? They will occur at different seasons. So what I will do? I will take the maximum of these two to find out what? The design discharge. Understood? Understood this concept or not? Understood? So I am going to find out the design discharge in this manner. Yes, so you have to see that both crops belong to the same season or different season. And how to find out discharge? That is area by duty. And how to find out duty? We know this formula, 8.64 B by delta. Okay, very important. Now solve this question. A water course has a this cultivable command area of 1200 hectare. Yes, so this is the CCA given, 1200 hectare, right? Now, the intensity of irrigation of crop A, so we have two crops. So for crop A, I will underline in, yellow, the intensity is given 40%. See, from intensity, what I will get? The area to be irrigated, right? Yes, I told you, the area to be irrigated will be how much? The cultivable area, cultivable area, and then into the intensity. And then crop B has intensity of how much? 35. Now crop A has a base period of 20 days. Crop A has a depth of irrigation of 10 centimeter, and crop B has a base period of 15 days and depth of 16 centimeter. Now what you will do? Very easy. You find out area 1 and area 2. You can find out area 1 and area 2. Yes. Suppose crop 1 I am giving number 1 and this crop B I am giving number 2. Okay. So find out area 1, area 2. You can find out area 1, area 2. Yes. Now see, the base period and depth is given. So you can find out D1 and D2. Yes. And then from here you can find out what? Q1 and Q2. A1 by D1, right? And Q2 will be A2 by D2. Yes. So you can add them and you can find. Now solve the question entirely and give me the answer. I am waiting for your answer. Okay. Very good, Santu. Very good. So area 1, we are getting how much? 40% of 1200. So 480 hectare, right? And then crop B, 35% of 1200. That is 420 hectare. Now use this formula, 8.64 and 8.64 base period by delta, and give me this duty. Give me duty. Give me the duties D1 and D2. See, very straightforward. The question is looking long, but people who know how to solve, they will solve within 1 minute. D1 and D2, how much you will get? 8.64, 20 by 0.1. You see, you have to take in 0.1. This is 0.1, right? 0.1 meter and this is 0.16 meter. Okay, so it is tell me the answer. Okay, duty 1728 and 810. Very good, very good, very good, Santu. Others, please pick up. Okay, tell me what's the answer now. Now tell me the discharges now. 15D. Very good, Vivek. Very good, Vivek. See, all these questions can be asked in your any PSU exam, GATE examination, ESE examination, and then you see your SSC JEE, any exam you pick, they can ask this question, right? So I have designed this question such a way that it helps you in all the examinations. Okay, not only this examination, all the examinations. Okay, the first discharge you're getting 0.28 meter cube per second. I am not solving, I have explained to you, and this you're getting how much? 0.52, right? Everybody understood these steps or not? Understood, everybody's understood step. Why it isn't? Both being kharif crops. This line was written, right? This line was written to you. Understood everyone how to solve this type of questions? Very easy. Now the same question, if the two crops belong to different season, then what would have been the answer? Tell me in the comment section. If I ask you that both the crops are of two different seasons, then tell me what will be your answer if they belong to two different seasons. Write down in the comment section, I am waiting for answer. If it was given that both the crops belong to two different seasons, then what will be the right answer? Please tell me in the comment section. 0.52, the maximum one. 0.52, the maximum one, right? Very good. Okay, next question, let us go to the next question. Okay, it's a very straightforward question. The saturation capacity, filled capacity and permanent wilting point are 47%, 27% and 14%. The available moisture, okay, for the crops grown in the soil in terms of percentage is how much? Tell me what's the right answer to this. Very good, very good, very good, very good. Very good. The answer is 13%. See, the available moisture will be always what? Field capacity minus the permanent wilting point. So here in terms of percentage, it will be 13. How? 27 minus 14. Very good. Okay. Very good. So 16 is the answer. Now something, okay, from your Lacey's theory. See, from your Lacey's theory, it is very difficult that, okay, they will ask you some what? Some numerical. Why? Because the formulas are what? Complicated. Yes. They have power 5 by 3, they have power 1 by 6. Yes. So you cannot solve them, okay, without the calculators. Okay. So they will be asking you directly the formulas. Many times they ask you directly the formulas. Very good, Santu. Very good, Afrit. What's the right answer to this? The normal depth of score, that is R. Yes. What is the formula? Direct formula, so remember 1.35 Q square by F. What is Q? Q is the discharge intensity or discharge per unit width. Yes. You see here it is C, Q square by F to the power 1 by 3. Okay. You see, they will confuse you with options. Yes. They will confuse you options. You see here it is only Q by F then 2 by 3. No. Q square by F to the power 1 by 3. Okay. There's some other formulas, right? There's some other formulas also. Yes. So those formulas also you should remember. Like you know, so you see, what was the velocity formula? It was Q F square by 140 to the power 1 by 6. And what is this F? It's the silt factor, right? Yes, it's a still factor. And this is how much? 1.76 root under the diameter of the silt in mm, right? Yes. So this kind of, you know, the formulas directly they can ask, because you see, you cannot solve this equation, right? You see, Q F square, right, by 140 to the power, you know, 1 by 6, how we'll find out. Huh? Some people can do, some great people can do, but you know, everybody can't do this, right? Or suppose I'm asking you the slope. The slope is what? F to the power 5 by 3, then 3340, Q to the power 1 by 6. You see these formulas, they can directly ask. They might not ask you numerical, but they can directly ask you formula, so you should know the formulas. Okay. Next thing, what is the permissible velocity of water in cement concrete lined canal as per IS this? Okay. So this is column also is there. So what's the permissible? That's kind of memory based questions also they can ask. So you have to be ready for all the type of question. Direct formulas, expressions, theory, numericals, factual data like this. They can ask many things like this. Okay. And as you know, we can see SSC, JE and other PSU examination, they will be mixing it very nicely. Very good, Karthi. Karthi has answered the right answer. It is 2.7. Yes, remember this. For cement concrete, it is 2.7. Now suppose I am telling your brick lining. Tell me, if I ask you brick lining, then it will be less or more, tell me. If it is brick lining, the permissible will be lesser or more, tell me. It will be lesser or more. If I am asking you brick lining, then lesser or more, tell me. Obviously it will be lesser, right? Because you see the cement concrete, it will be difficult to, tear it, right? So I will allow more velocity. For brick lining, remember it is how much? It is 1.8 meter per second. Yes. And for stone lining, yes, it will be little less than that, than 1.5. Yes. So remember these values, they can ask this. Okay. They can ask this. Okay. Next thing. Okay. Capacity factor. Capacity factor. What is the capacity factor of channel? You see from the question only you can guess if you don't know the answer also. If you don't know the answer also, from the question also you can guess it. From the question also you can guess it if you don't know the answer also. Yeah, very good civil engineering knowledge. Yes, very good. You see it is the capacity factor will be the average discharge by the full supply, or I can say maximum discharge, right? So from the question also you can guess it. It is how much? 40 by 60, that is equal to 0.67. Straightforward question. Okay. So this question I will answer, you will answer after I explain some things. Yes. This is something known as what? Conjunctive irrigation requirement, CIR. Yes. This is the actual irrigation requirement by the plants. This is what? Consumptive. Okay, I am not writing the IR, conjunctive irrigation requirement. Now, in addition to this CIR, you will require some more water, right? Okay, some more water for leaching and other purposes. Okay, so for leaching and other requirements, processing and all, you will require some more water, and that is known as what? The net irrigation requirement. This term is what? Net irrigation requirement. Now, there is something known as the field irrigation requirement. Yes, that will be equal to the net irrigation requirement divided by what? The application efficiency. This is what? This is your water application efficiency. Why? Because you see, this much is net requirement. This much is what? Net requirement. But when you are providing, there will be some losses. Some will drain out, some will flow. Yes, surface runoff will happen. Therefore, this water application, yes, applying on the field, right? You are applying on the field, and therefore that water application efficiency will come into picture. And obviously this efficiency will be less than 1, right? And then last we have the gross. This is what? This is the field, right? And last one is the gross. The gross one will be equal to the field irrigation requirement by what? The conveyance efficiency, water conveyance efficiency. Why? Because when you are providing to the field, before providing to the field only, there will be some losses, right? Before, see, two type of losses. See, first loss will be what? Before you provided to the field, okay, in the canal only, in the that only there will be losses, right? And then when you provided, then there will be losses, right? So while conveying, there will be losses. So from your field, if you want to find out the gross requirement, divide what? Water conveyance efficiency. Everyone is clear of all these 4 terms? Yes. CIR, yes. Then NIR, then FIR, and then GIR. Now, if I ask you the order of this thing, tell me what is the order? What is the order? suppose I ask you decreasing order. If I ask you decreasing order, tell me the decreasing order, tell me. The decreasing order, tell me. Which one will be more, and tell me the decreasing order. Tell me. Tell me the decreasing order. Come on. Very good, Santu, very good. No, 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 no. Net is less. Net will be lesser, right? Net will be lesser. Okay. First one is gross. Yes. That will be, see, gross requirement will be more. Gross is from the source, right? Gross is from the source. Now till the time it reaches field, there will be some losses. Yes. Now from the field, when it reaches the root zone, the net requirement, it will be less. And then in the root zone, I can say some will be utilized by the plant and some will be used for leaching. So that means what? This is the least one. Yes. So everybody understood this thing, right? It's a very important concept. Now you can easily solve this question. Please answer this question. Now you can easily answer this question. Please answer this question. I'll have some water by that time. NIR is given. Okay, water application efficiency is given and water conveyance efficiency is given. The gross requirement is asked. Very good, Santu. Yes. So I can directly write down NIR is equal to what? Your FIR will be equal to what? NIR divided by your application efficiency. And GIR is what? It is your FIR by conveyance. Rightly it will be what? Net divided by application and conveyance. Right? So it will be 15 centimeter. Whenever you use efficiency, you don't use in percentage. Use in the decimal. So 0.6 and 0.8. So this is the right answer. Okay. Straightforward question. Very good. Now you can easily answer such kind of questions, right? Okay. 21. The elementary profile. I'll explain to you. Okay. The elementary profile is a triangle, right? The elementary profile of a gravity dam is a triangle. Direct formula I'll derive for you. Remember it. Not derive. I'll just write down here. Don't have time so much. This H, this is B. Yes, the triangular profile. And here we have two conditions. Here we have two conditions. No tension. This is heel actually. No, very good, very good. Many have answered also. No tension at heel. Okay, this is the heel. Yes, this is the heel. No tension at heel condition and no sliding condition, right? So no tension at heel condition, the equation is what? B by H should be greater than equal to your 1 by root under specific gravity minus coefficient of uplift. And no sliding condition is what? The no sliding condition is, yes, B by H should be greater than equal to your 1 by mu G minus C. Okay, so these are the equations which you should remember, right? Remember. Now here if they have asked what? No tension development at the heel. So from here I can say B will be, I'll take this H this side. So H by root under G minus C. So this is the right answer. Sometimes in place of C they write down K also. Same thing, right? Sometimes they will write K in place of C. So don't get confused. Okay, very good. Next question, 22nd question. Cross drainage. Cross drainage. Okay. Now I'll answer this question. Before that, I'll explain some things. Okay. I'll explain some things. Okay. In cross drainage, they will be asking you 4 types of cross drainage. Okay. First one is aqueduct. Okay. Second one is siphon aqueduct. Second one is what? Siphon aqueduct. Okay. And then the third one is your super passage. Okay, there are many, but I'm discussing the prominent one which they can ask. And the last one is your, canal siphon. Or if they write down siphon only, then it refers to what? Canal siphon only. See, if they write, siphon aqueduct, then that is siphon aqueduct. If they write canal F siphon, then canal siphon. If they write only siphon, that is what it is, canal siphon only. The super passage and then aqueduct. Now, first of all, what are these structures? These cross drainage structures are what? They're something similar to this. Okay? They're something similar to this. Now, what is this? You can see that we have two waterways, right? We have two waterways. There will be two waterways. Okay? One will be known as the drain or the stream. Okay? That's what I am discussing. Just wait, I am discussing. So there will be two waterways. You can see there are two waterways. One will be what? The drain, or I can say the stream, or I can say the river. Right? River. Right? The second one is what? The second one is the canal. Yes? Second one is the canal. Right? Understood? Now here you can see that this is what? The drain, right? The drain, stream or river. Yes or no? The drain, you can say drain or stream or river. Right? And this is the canal. You see, this is the canal. Yes, this is the canal. Now, the canal will have two levels. Its base will be known as what? CBL. Means what? Canal bed level. And its maximum flow will be known as what? FSL. Full supply level. Understood these two terms? Full supply level and then canal bed level. Understood? Very good. Canal. Very easy. In a canal you will provide, it will be bed, yes, and obviously it will have a full supply level also, right? Now similarly the drain or stream will have two levels. One will be what? The drain bed level. The drain bed level. And the second one will be known as what? The HFL. High flood level. Because the flood can come in, actually canal's flood will not come, right? Because canal you can control, right? Canal you can control. Only what you can do? You can supply it full, right? You can supply it full. Okay? Supply it full. And then, we are discussing this, so let us first discuss this. Uplift will discuss some other day. I have taken one lecture on this gravity dams. You can refer that lecture. I have taken stability of gravity dams in the channel. That full full explanation I have given there. Okay? You can just refer that lecture. So here, coming back to this, everybody understood these terms or not? Tell me. Everybody understood these terms or not? DBL, CBL, FSL and HFL. Please tell me, everybody understood these four terms or not? Everybody understood these four terms or not? Tell me. Yes? Others clear? Very good. Now, depending upon this relative position of these four levels, we will have different cross drainage. Very easy, you see. See, in both aqueduct and siphon, remember, the drain will be below. Yes, drain will be below. Yes, so this will be the DBL and this will be the DBL, right? And what will be above? CBL. The canal will be above the drain. The canal will be above the drain. Yes. And obviously, full supply level, FSL belongs to what? It belongs to the canal. So obviously the FSL will be somewhere here, right? And here FSL will be somewhere here, right? Yes. Now what is the difference between aqueduct and siphon aqueduct? Very easy. In case of your aqueduct, the HFL will be below the CBL, and in case of siphon aqueduct, the HFL will be above the CBL. Everybody understood difference between aqueduct and siphon aqueduct or not? Tell me. Everybody understood the difference between aqueduct and siphon aqueduct or not? Yes. Now tell me, what is this? This is what? This is an aqueduct or a siphon aqueduct? Tell me. This is an aqueduct or a siphon aqueduct? Tell me. Tell me what is this? This diagram is what? This is an aqueduct. You see, this is the drain. Yes, drain is below and canal is above. Okay, very good. But we can have two cases in this, right? But you see, this I can say is what? Suppose here, somewhere here, you see, somewhere here will be what? Somewhere here it will be what? Your CDL, right? Somewhere here it will be the CDL, sorry, CBL, sorry. Canal bed level. And you see this level is what? This is the HFL. Yes, this is the HFL. Yes. Or suppose it increases little bit also. You see there is some gap, right? Suppose little bit also. There is a gap between the high flood level of the drain and what? The bed of the, yes. So this is what? This is an aqueduct. This aqueduct, you see. And you see the drain bottom DBL is very below. We can't see it here, right? We cannot see the DBL. Everybody understood this or not? Everybody understood this or not? Tell me. Difference between aqueduct and siphon aqueduct. Now the reverse. Just take the reverse. Reverse is what? Reverse will be, this will be your DBL. Yes. Drain is above and canal is below. Then that is what? That is your super passage. Similarly, here also DBL is above, yes, and CBL is below. So what's the difference then? What's the difference? Similar difference. You see, if this is the DBL, then obviously the HFL will be above it, right? The HFL will be above it, no doubt about it, right? The HFL will be above it, okay? But in case of your super passage, the FSL will be below the DVL, and in case of canal siphon, the FSL will be above what? The DVL. Everybody understood these four things or not? Now better is to understand from this diagram than the actual diagram. Actual diagram can be confusing, but this diagram is not confusing, right? Yes, actual diagram can be confusing, but this diagram is easier to understand. So aqueduct and siphon aqueduct, they are similar. How? DBL is below, drain is below, canal is up. Okay? And in super passage and your canal siphon or siphon, yes, the canal is below and the drain is up. Yes? Only difference is what? Here, you see HFL is below this. Means basically I can say that in your aqueduct there is some gap, right? There is some gap. But you see in your siphon aqueduct, or I can say canal siphon, there is no gap. They're overlapping kind of thing, right? So everybody understood now? Now you can easily answer this question. Tell me what is the answer to this? Answer this question. It is an aqueduct. What is written? The canal bed level CDL or CBL, sorry, is kept higher than the HFL of the stream. HFL of the stream. Now they can ask questions like this also, you see. They will ask question like this, very simple question, you see. They will ask you, suppose I am telling you, okay. I am just giving you one data. Suppose I am telling that CBL is equal to 105 meter. Okay, then DBL is equal to 111 meter, okay, and then your FSL is 114.2 meter and your HFL is 117 meter. Tell me what is this? Okay, and that is different, that is pipe flow siphon is different, okay. Here we are discussing only the cross drainage, that is different. That is different. That is we have to study pipe flow. That I have explained in a video in fluid mechanics. In pipe flow I have explained. You can download the app and that is available. I cannot teach here in pipe flow now. Now just here they will ask you this. So I am discussing only that much only. So what's the answer to this? What is this? This is siphon aqueduct or something else? Just plot them. 105, 111, 114.2, 117. Yes. So below is CBL, right? Then we have the DBL. Yes. And then we have the FSL, right? And then above that we have HFL. This is what, ladies and gentlemen? What is the answer to this? See your diagram. You're not drawing, you're seeing movie. Huh? I'm shocked, stunned. It is siphon. It is siphon. Canal is below. You see, canal is below. It cannot, see, canal is below means it cannot be aqueduct, right? Canal is below means it cannot be aqueduct. So either it will be canal siphon or it will be a super passage, right? Or super passage, yes. So you see here, it is overlapping, right? You see it is overlapping. Yes, this is the FSL, this is the HFL. Yes, so this is what? A canal siphon, or I can say simply a siphon. So everybody understood the type of questions they can ask? Yes. No, not a super passage. Here it is not a super passage because see, super passage if this FSL was below DVL, right? So everybody can answer now questions from these four things or not. They can ask you, see, they can draw and they can ask which is what. They can form numeric question like this. They will give the levels and ask you, or they might ask in words. Okay, they might ask in words. So these four are very important. I explained to you. Okay. Next is, okay, Lacey's theory has a velocity, silt factor, hydraulic mean depth. R is equal to what? The formula is what? Empirical formula 2.5 B square by F. Okay. So Lacey's theory formula which can be easily solved, you should remember them. Now tell me the right answer to this. Come on, patapat, we are going late little bit. Come on. 2.5, simple, 0.88 square by F. Some questions will be very simple, straightforward. How much I am getting this answer? Straightforward, 1.76, very good, 1.76B. Next question. Okay, this question we solved, right? We discussed this question sometime before. Answer this 24th question fast. Very straightforward question. CIR, NIR, FIR, yes. And then this is what? GIR, yes. Straightforward question. Answer is what? B. Correct relationship is asked. So we solve this, yeah? Very straightforward, okay? Okay, the sodium absorption ratio SAR is given as 12. So it belongs to which type of sodium? Now first of all, this is what? This is Na plus concentration divided by what? Your, I'll write down here, space is less. What is SAR? SAR is your Na plus concentration divided by what? Root under calcium concentration plus your magnesium concentration divided by 2. Yes. So it belongs to which category? If it is 12. Okay, the answer is what? Very good, Vivek, Afrid, very good. It is B. Medium sodium water. Remember, SAR range I am giving you. If it is 0 to 10, okay, we call that as low sodium. Yes, if it is 10 to 18, we call that as medium sodium. Okay. If it is 18 to 26, we call that as heavy sodium. And if it is more than 26, then very heavy sodium. Okay. So, as per the given data, it is how much? 12. So, I can say medium sodium. Next question. Okay, the next question is about finding the SAR. Find out this. Find SAR. Give me the right answer. Fatapat. So all the type of questions we are solving, okay, not only theoretical but numerical, many things we are solving. Please solve this and tell me the answer. Sodium concentration is given 20 divided by calcium is 10, magnesium is 8 divided by 2. So 20 divided by root 9, 20 divided by 6, 6.67. If they ask you which category, it is low sodium, right? It is low sodium, right? Because less than 10. Next question, okay. Which type of irrigation is practiced when the water supply is too low a level to run by gravitation of the land? Okay, if the water supply is too low that we cannot use the gravitation property of that area to supply water, then which irrigation we do? What's the answer? We cannot do flow irrigation, right? Because the gravitation we cannot use because the flow is very less. So if the flow is very less, then I cannot use flow irrigation, right? So what's the answer to this? I cannot use flow irrigation because the gravitation is less. Gravity is not less. The water supply is too low that we can use gravitation. The answer is A. We have to do lift irrigation. We have to use pumps to lift the water, right? Yes, straightforward question from hydrology. Okay, the number of rain gauges. Okay, the number of rain gauges. What was the formula? Coefficient of variation divided by the allowable area square, right? This is the formula for what? For finding the optimum number of stations or gauge stations, or I can say optimum number of rain gauges. Straightforward formula. Please tell me the right answer to this now. What is the answer to this? It will be 29.54 divided by 10 square. Yes, you're getting how much? Total 9. Getting how much? Total 9. Because you're getting 8 point something, 8.7 or 8.8 something you're getting. Okay, 8.7. So I have to round to the next story. Next question. Okay. So your normal ratio method, right? Normal ratio method. Yes. Missing data. You have to find out what? Missing data. You see. Okay, the normal rainfall data are given. These are what? NIE I can say. Yes. And these are the actual precipitations, right? Actual precipitations. So what was the formula to find out the missing one? What's the formula finding the missing one? The missing rainfall by the normal rainfall of the missing station will be equal to the summation of P by N of remaining stations divided by the number of remaining stations. Yes. So here remaining stations is how many? 2. So M is 2. Okay. So find this value and tell me the answer. Find this value. This is the formula. Yes. So you here see this is the missing one, right? This is the missing one. So P by the N of the missing one is how much? 250. And the remaining ones are how many? 2. So 1 by 2. And then summation of P by N of the remaining. P by N. 140 by, this is P and this is N. So 140 by 200 plus 270 by 300. Yes. So if you solve this, how much P you are getting? Extra total, optimum number, optimum total. P is how much? 200 mm. You are getting 200 mm, everyone. Very easy, normal ratio method. Okay, normal ratio method. Okay, very good. Let us go to the next question. Okay, phi index. Phi index. How to find a phi index? Very easy. What is phi index? Phi index is the total rainfall. It is what? The total rainfall minus the total runoff. Okay, total rainfall minus total runoff divided by time duration. So you see, when I am finding this, I'll add all the rainfall. You see, all these are what? 1 hour rainfalls. You see, mm per hour. Total 6 hours it rained. It is per 1 hour. So I can add all this. 7 plus 8 plus 25 plus 17 plus 11. This total rainfall. Minus the runoff is given 39. And total duration of rainfall is 6. So how much I'm getting this? If I solve this, how much I'm getting this? 7 plus 8 plus 25 plus 17 plus 11 minus 39 divided by 6. I'm getting a value of 4.83. Some calculation that I did. How much are you getting? First, 4.83 you are getting. How much are you getting? Tell me the answer. Yes, we are getting 4.83. Yes, we are getting 4.83. some data, yes, something is the problem. Okay, 4.83 I'm getting. So you see this 3 mm. Okay, 3 is not added. Yeah, that's what I was feeling. Okay, that's what I was feeling, that some problem is there. 7 plus 8 plus 25 plus 17 plus 11 plus 3 minus 39 divided by 6. Again some problem is there. How much I'm getting? Some problem is there. My calculator is having problem, or you are not. Why you are not solving? You also solve and tell me. Why I'm getting some wrong answers? No, I'm not getting wrong answers. 5.33. Oh, correct. I'm getting here 7 mm per hour. Yeah, this is the first step. The first step. Thank you very much, Arsenal. Okay, so this is the first step of finding what? The phi. But you see that we have two intensities less than that. So you have to less than or equal to that. Subtract that, because all this thing will run out. So I will subtract that. So now what will happen? The remaining one is what? 18 plus 25 plus 17 plus 11 minus runoff will remain same. Yes. And then now the rainfall duration is what? 1 hour, 2 hour, 3 hour, 4 hour. So how much I am getting here? 80 mm per hour. The standard question of finding what? The phi index. Okay. So many standard questions we have solved, and we can see that the coverage is good for this series. Okay. So here the phi index is given, and find out the runoff depth. Answer me this question, fatapat. The phi index is given to find out the runoff depth. Yes. And you can see all these are what? 1 hour rainfalls, right? 1 hour rainfalls. What's the runoff? Runoff will be what? Runoff will be equal to rainfall minus the infiltration, right? And your phi index indicates what? It indicates infiltration only, right? It indicates the infiltration. So what's the answer to this? So find out the runoff for each interval. Yes. See, the first hour runoff will be how much? It will be 0. Why? You see, you will be getting rainfall is what? 9, and your infiltration is 10 mm per hour. So in 1 hour it will be 10 mm only. So it cannot be negative, right? It cannot be negative. Yes, you cannot have negative runoff. Okay, so it will be 0 only. Second one will be how much? 28 minus 10, that is what? 18. Next one is what? 12 minus 10, that is what? Your 2. And the next one is again 7 minus 10. So it is minus 3, but it cannot be negative. So what? 0. 0. Now some people, what they do, they take this negative value also. The negative value also, and what they give? They give 20 minus 4, that is 16. So this is not right answer. Okay. It won't be 20 minus 4. Why? Because you cannot have negative runoff. Yes. Okay. 31. 32, straightforward question. Isoplates are lines on map through points having equal depth of what? You see, when we have equal rainfall, they are known as isoheight, right? We have discussed this. Now, what is this isoplate? Isoplates are having equal what? Your evapotranspiration, that is isoplate. Remember. Okay. Next thing. Okay, the equivalent runoff coefficient is asked. So very easy. See, different areas are given and the runoffs are given. Runoff coefficient are given, right? So I can say this as what? This as, you know, AI, and this is CI. So I can find out the equivalent one. Very easy. The equivalent one will be how much? It will be equal to CI AI summation divided by what? Summation of AI. Very easy. So if you take the summation of, you know, CI AI, 7 plus 2 plus 15, 7 plus 2 plus 15 plus it is 16, okay, divided by total area is how much? 30, 100. So it is how much? I am getting 9, 40 by 100, that is equal to 0.4. Understood? Very straightforward question. Very straightforward question. Okay. Next question. Okay, on current meter. How to solve questions on current meter? The current meter, we have the formula. This is from flow measurement of hydrology. What is the formula for velocity? Is a constant n into the number of revolutions per second. The number of revolutions per second plus b. This is the equation, right? Now they have given some data. Let us see. The number of revolutions for a current meter in 60 seconds was found to be 12 and 30 for velocity of 0.2 and 0.35. So two velocities are given, 0.2 and 0.35. Yes. Now this will be what? A into ns plus b. This also will be A into ns plus b. Now A and B for a current meter will be same, but the number of revolutions will be different because velocities are different. Now the number of revolutions for the first case is what? It is 12, and second case is what? It is 30. From here you can find out A and B. Yes, but this is wrong because what I told, what is ns? It is what? Number of revolutions per second. It is what? Number of revolutions per second. So it will not be 12. It will be 12 by 60. 12 divided by 60. So how much I am getting? 0.2. And second one is what? 30 revolutions. So 30 revolutions per second will be how much? 0.5 because 60 seconds. So from here you can find out A and B. Yes, from here you can find out what? A and B. What they're asking? What is the velocity when 50 revolutions happened in 50 seconds? If 50 revolutions happened in 50 seconds, then what is the revolution per second? It is 1, na? That means what? Your ns is 1 here plus b. So this velocity is what? A plus b. So you have to just find out A and B and add them to get the velocity when this is the data given. This is what? From flow measurement. So give me the answer to this. To give the answer to this, you can just subtract this, right? If you subtract this, what will happen? You make a minus here, and minus here. B will get cancelled. I'll get 0.3. A is equal to 0.15. Or A is equal to, I will get 0.5. And B is equal to, I will get, if A is equal to 0.5, B I will get 0.1, right? So this answer will be how much? 0.6 meter per second. Understood everyone this question from current meter? Yes, the answer is 0.6. This is what? Current meter, which is used for your flow measurement. And this is the formula. So remember this formula, right? A and B are constants. And what is ns? ns is equal to, remember this one, many students commit mistake in this. It is not number of revolutions. It is what? Number of revolutions in the current meter per second. It is number of revolutions per second. Understood everyone? Very good. Next question. Okay. The unit hydrograph theory is based on the assumption of what? It is based on two assumptions. Okay, the theory question. So two assumptions are what? What are two assumptions? Come on, fast. Hurry, Baba. Nobody is answering. The answer is C, time invariance and linear response. What are the two terms? Time invariance means what? If you have drawn a hydrograph, a unit hydrograph for an area, for suppose D hour rainfall, you have drawn a unit hydrograph, okay? If you have drawn a unit hydrograph, this unit hydrograph will come same if you are conducting that rainfall in month of March or April or morning or day, afternoon, any time, this hydrograph will remain same. Time invariance. It will not vary with time. And second one is what? Linear response. What is linear response? That you can add two discharges, right? When you are having, when you are building, complex hydrograph from two hydrographs, what you do? You just add them, right? You just add them, right? Or suppose I am preparing what? A 2-hour unit hydrograph from 2 1-hour unit hydrograph. So what I do? I just add them, right? So this is what? Linear response. They are linear related, so we can add them. We can add the data points. Okay? The two assumptions. Now S curve. In the S curve, they are asking you what? your equilibrium discharge. Yes, we know that S curve we get when we repeat a unit hydrograph for infinite times, right? And this is the saturation discharge. You can say after this the discharge will be constant, and the saturation discharge formula is 2.778, and this will be in meter cube per second, area by the duration of the hydrograph. So if we have a d hour hydrograph, so this is the formula, and this will be in kilometer square, and this empirical formula, not empirical, we derive it actually, but you know, I am not deriving it here now, we have left time actually. This is what? In your hour. So what's the answer to this? What's the answer to this? It is 2.778, yes, area is 270, and it's a, okay, here it is not written, 3 hour unit hydrograph. 3 hour, oh, it is visible, if it is visible, 3 hour, it is visible, slightly visible, right? Slightly visible, yes, 3 hour unit hydrograph, right? So you'll get cancelled, 90. See, you can, you know, without calculating also you can find out, right? You can see this will be 27.78 into 9. So obviously around 250, right? You can guess it also, right? Okay. So next question is, okay, answer this question. A 12-hour hydrograph of a catchment is triangular in shape with a base width of 114 hours and a peak discharge of 23 meter cube per second. T refers to the catchment area, and what is the catchment area? How to find out this thing? How to find out the catchment area? Very easy formula. For any hydrograph which is either a direct runoff hydrograph or a unit hydrograph, what's the formula? The formula is area of catchment into effective rainfall. Into effective rainfall, I can say rainfall excess, right? I've taken one lecture on hydrographs, there I've explained this formula. The area of catchment into your rainfall excess becomes equal to what? The area under DRH, or your unit hydrograph, because unit hydrograph is also a DRH, right? Now, how this formula comes? You see, what is a DRH? It is what? Discharge versus time, it is a hydrograph. So if you take this area, it is meter cube per second, and time is what? Second. So meter cube per second, and second will give me what? The volume of water discharged. And the volume of water discharged will be what? That will be equal to the rainfall depth into catchment area, right? If we have a catchment area, yes, like this, A, and suppose we have a certain, you know, depth of rainfall, yes. So this will become the volume, right? This will become the volume, and this volume will be available at the outlet as total discharge water, right? So you can use this relationship and you can easily find out what? Whatever they asked. Now it's a unit hydrograph. Unit hydrograph means what? Your rainfall excess is 1 centimeter for a unit hydrograph. And it's a triangular area given for the unit hydrograph. Yes, the base is given 114 hours and the peak is asked. Right? Suppose the peak is in meter cube per second. Okay. So I can say that from this thing, what I can write down? You see, the area under unit hydrograph will be how much? Half. Base is 114 hours. I'll convert these hours into what? Into second, and then multiply this discharge. QP discharge is how much? 23 here. So I'll get this in meter cube, right? Converted everything into meter cube per second and second. So meter cube. This will be equal to the area of catchment I'm trying to find in kilometer square. So kilometer square I'll convert into meter square into per 6, and the rainfall excess is 1 centimeter. That is what? 1 into per minus 2. So this is centimeter meter cube. Why? Because you see, this side it is meter cube, this side is meter cube. So it should convert such a way that both sides I get meter cube. You see, this was days. So days into, so day has, or here 24 hours also have to multiply. Day to, or it is hours only, sorry, hours. So hours to minutes, minutes to seconds. So second into meter cube per second give me meter cube, and this is kilometer square, 10 to the power 6 meter square, and then 1 centimeter 10 to the power minus 2 meter, so meter cube. So what's the answer to this? How much you are getting? Okay, 471. Okay, let me just check. Triangular in shape with, there might be some misprinting of data. Yes, some misprinting method happened. But you're getting 471? Okay, then let us answer this as 471. There might be some misprinting, okay? Sometimes it happens now, we misprint, okay? But the concept is this. A 12-hour hydrograph of a catchment is triangular in shape. Yes, triangular is given triangular only, not rectangular. With base of this much and discharge of this catchment area is this. Okay, there might be some typing mistake, okay? Okay, next question is a 12, okay, the same question only, okay? Okay, base period of a 6-hour unit hydrograph of a basin is 84 hours, okay? So if a unit hydrograph is there, okay, so this is the 84 hours, the base is 84 hours, okay? The base of a 12-hour unit hydrograph of the same basin, what will be the answer to this? Very good, Santu, very good. Very good. The answer is what? A. Others are not studying. Not good, not good, not studying. You see, it is 84 hours, a 6-hour unit hydrograph. How we get a 12-hour unit hydrograph from a 6-hour? We repeat the hydrograph after D duration, right? You see, this is the D, right? D hour. So we repeat the hydrograph after D duration, right? Yes. So we repeat it after D duration. And D is how much here? Here 6. Yes. So we repeated this 6-hour in hydrograph 2 times, right? And therefore now this will become the base, right? This will be how much? Diagram it is 90 hours. Very straightforward question. Now this is on specific yield. I'll give it at the formula, okay? The specific yield of a aquifer is equal to the water pumped out. It is what? The water pumped out divided by what? Divided by the drop of volume of water from aquifer. Okay? From your aquifer. You see, here what has happened? You have pumped out water. How much pumped out water? 3.5 10 to the power 6 million means 10 to the power 6 meter cube water is pumped out. Okay. Now see drop in the volume of water. You see it has gone down by 2.5 meter. This is what I can say the delta H. Delta H, the drop in the height of the water level in the aquifer. Now the area of the aquifer is this. So if I multiply the area, see area won't change. If I multiply the area 10 to the power 6 suppose, because I want to convert into meter cube, okay. So I'll get the change in volume, the drop of volume. This will be how much? 2.5 meter into what? 6.3 into 10 to the power 6. So if I find out this specific, it will be how much? It will be, you see, 3.5 10 to the power 6 divided by 6.3 10 to the power 6 and then what? Your 2.5. Now this will be coming in what? In decimal. If you multiply 100, you will get in percentage is 22.22 you will get. This is the right answer. Last question. Okay, very straightforward. It's easy one I have given. Okay, last question. Muskingum model for flood routing. We use this for flood routing. Yes. So here we have 3 constants, right? K0, K1 and K2. Okay, I'm not discussing the constant. I'll discuss this when I discuss the formulas for your hydrology. Tomorrow I'll be doing that. So what's the right answer? That answer is this K0 plus K1 plus K2 is equal to 1. We're discussing the formulas, okay? Tomorrow we have a discussion class on the formulas. We are going the formula series. Tomorrow we'll see. So this completes our 40 questions today on what? On your hydrology and irrigation. These are the most probable questions for the upcoming examination. Hope you enjoyed the lecture and I tried to cover all the important objectives from hydrology and irrigation. Yes. And almost I think that we have covered a very good range of questions from different, chapters and a mix of, numericals and theoretical questions. Yes. Thank you very much. So like this, tomorrow we have for highway engineering. So tomorrow also I'll be solving around 40 questions, similar questions from highway. I'll be discussing highway and I'll be discussing railway airport also for your upcoming examinations. So tomorrow 11 AM we have a class here. Okay, so welcome everyone. Tomorrow 11 a.m. same time, around 40 questions we'll solve. And I'll request you that you please have a revision of the formulas. Yes, I will request that you have a revision of the formulas. If you revise, then it will be good. But even if you have not revised, then I will teach also. I will not only solve the questions. I'll give the background theory also if required for some questions. Okay. Thank you very much. See you tomorrow at 11 a.m. Bye.